Chapter 6 deals with conic sections. Basically think of a cone that is sliced in a number of ways and the kind of graphs that you could have by those slices. We're going to look at three different types, parabolas. We're going to skip the circles, but we'll look at ellipses, which are related to circles. They're just not equidistant all the way around. And then we'll look at hyperbolas. Today we're going to look at horizontal parabolas. A horizontal parabola has the form in which basically we switch the x and y. So notice that it's x equals, and it's the y part that is squared. Its vertex will still be hk. It's just that now the k part is the one that will have the opposite sign, whereas the h part will have the same sign. The axis of symmetry we get from what's inside the parentheses, so y equals k. If a equals 1 and it's at the origin, this one has the form y equals x squared. So basically it opens left or right instead of up or down. Now a parabola is a set of points in a plane equal distance from a fixed point, which is called the focus, and a fixed line, which is called the directrix. These are things that we didn't really worry about before in looking at parabolas, so this is kind of the new part. The focus again is inside of the parabola, and then the directrix is a line that's outside, and in this case to the side. The distance from the vertex to the focus is the same distance from the vertex along the axis of symmetry to the directrix. Now, if we had wanted to include these before, we could think in terms of a parabola that would be opening up, and again the focus is always inside the parabola. The directrix is a line that is outside of the parabola, and these two distances here and here are the same. Okay, so for a vertical axis of symmetry with the vertex 0, 0, the equation of the directrix is y equals negative p, and the focus is at 0p. And the equation for the parabola would be y equals x squared over 4p. For a horizontal axis of symmetry, this would be a horizontal axis of symmetry. The directrix is at x equals negative p, the focus is at p0, and the equation for the parabola is x equals y squared over 4p. So you can see the way the two forms go. Again, this would be for the parabolas that we've been dealing with so far, and then this would be for the ones that are horizontal. If the vertex is not at the origin, the vertex has the form of y equals 1 over 4p x minus h squared plus k. So really, this is vertex form, hk. The only thing that's new that we weren't dealing with before was the 1 over 4p. A lot of times this was 1, which the only way that would work is if p was 1/4. And so the focus would not have been very far from the vertex in that case. And then if we want a parabola that opens left or right, in other words, it has a horizontal axis of symmetry, we just switch the x and y. It's 1 over 4p. Now it's y minus k squared. So that's the basics of this first section. Let's go ahead and look at a couple of examples. So we want to find the vertex, the axis of symmetry, the focus, the directrix, and the domain and range for each of these parabolas, and then we're going to graph them. So again, vertex, we're going to take the x part first, and then the y. Again, it has to be opposite sign of what's ever inside of the parentheses, so vertex will be negative 2, 3. Basically, think of it this way. If we plugged in negative 2 for the x, this whole part would be 0 and y would be equal to 3. Okay, now axis of symmetry would be x equals negative 2. It has to match that. Notice that this is a line. Okay, so you can't say axis of symmetry equals negative 2. No, it's x equals negative 2, which we can get by setting what's inside the parentheses to 0. Now, the form, if we go back up here, the form is 1 over 4p, and then the rest of the equation. So that means here that 4p equals 20, because 1 over 4p, 1 over 20. So that will give us p equals 5. Okay, now this particular parabola, this is one that opens up and down. In this case, it's going to open up because this is positive. And so the focus has to be above the vertex by 5. And so the focus will be negative 2, 8. Again, notice how the y was 5 above what the vertex was. And then the directrix has to be a vertical line that is 5 below our vertex. Since the vertex is 3, 3 subtract 5 would give us negative 2. And so y equals negative 2. Now again, notice that this is a line. Okay, and so again, you can't just go directrix equals negative 2. Now, this is coincidental that the axis of symmetry and the directrix both look the same, except one is x and the other one's y. That does not at all have to be true. Now, since this is a parabola, the domain will be all real numbers. Don't forget that the domain always goes with x. And then the range, well, again, this is always going to be positive. The smallest it can be is 0 if I put in a negative 2. If I put in anything bigger than negative 2, like negative 3, negative 5, that's what I mean by bigger in terms of its size, that just is still going to end up as a positive. So the smallest I can get out of this is negative 2 and 2, which is 0. So that means y has to be greater than or equal to 3 for the range. All right, now let's look at a graph. I'll do it over here on the side. X and Y. So we know that the middle is going to be the negative 2, 3. So I'll go ahead and put that in the middle. Now, because of that 1 over 20, this thing is not going to go up very fast. It's going to be much shallower than a typical parabola that we've dealt with. So I'm going to move over a few each time. So if I go to 1, so that would be 1 plus 2, which is 3. 3 squared is 9, so that's 9 over 20, which is 0.45 plus 3. So this would be 3.45. So as you can see, it didn't go up very much. So that was 3 to the right. So if I go 3 to the left, which would be at negative 5, that will also be at 3.45. Again, there has to be symmetry about the middle, about the vertex. Okay, if I next go to 4, so this is 4 and 2, that's 6. 6 squared, 36. 36 over 20. ends up being 1.8. 1.8 and 3 is 4.8, which I move 3 that way, so I'm going to move 3 this way. That'll also be 4.8. And let's see, let's go to 6 now. So 6 and 2 is 8. 8 squared, 64. 64 over 20. We'll add another 3.2 plus 3, so that's 6.2. And so negative 10 is 6.2. We'll do one more for this. Since it's still not growing very fast, I'm going to go to 12. That's 12 and 2 is 14. 14 squared, 196 over 20. So that's going to add 9.8 plus 3, which will give me 12.8. And so let's see, negative 16 will also be 12.8. So there are our values. So first off, we have the vertex at negative 2, 3. So 1, 2 up to 3. And then we have 1 is about 3.5. So 1 is about 3.5. Let's see, and then across from that, negative 5 is about 3.5. Then we've got 4 is 4.8, so not quite up to 5. And so negative 8, 2, 3 is almost again up to 5. Then we've got 6, which is at 6.2, so 6.2, that's about right there. And negative 10 is at 6.2. So as you can see, it's a very shallow parabola. And let's see, we go up to 12, and we're at 12.8, so 12, that's almost 13. So we'll put it right there. And then at negative 16, again, almost 13 up there. And so there are the parabola. I'm going to go ahead and draw it out, connect my dots. So there is the parabola. Now, in addition to that, we have here was the vertex. The focus was at negative 2, 8. So this is where our P is. That's the negative 2, 8. And that was 5 up. 5 down is the directrix, which is at y equals negative 2. So we can draw that. And I'm just doing a dashed line because it's not actually part of the graph, but this is where the directrix is. Y equals negative 2. And then, of course, we have our axis of symmetry, which has to go right through the middle. And this one is the axis of symmetry, and it's at x equals negative 2, and I should say this is the directrix. And so for the type of parabolas that we've done in the past, except for the fact that this is so much shallower, you can see not only the vertex that we had before, and again that was negative 2, 3, that's the vertex, and then here is the focus. And then we have the axis of symmetry at x equals negative 2 and the directrix at y equals negative 2. Alright, so that's for a typical north-south type of parabola. Let's now look at one in which we switch the x and y. So this one's going to go left or right. In this case, since we are, again, everything's positive, this will open to the right, open to bigger x values. So let's first start off with our vertex. Okay, and it's going to be 3 and 2. Now, please note, okay, if this is 0, then x equals 3, so that's the 3 part, but it's always got to be opposite sign of what's ever inside the parentheses. So there is our vertex. Axis of symmetry is y equals 2. Again, since we've switched the letters, here the axis of symmetry is going to be horizontal, where over here it was vertical in the other one. Alright, so in this case, 1 over 4p equals 0.4. That leads to p equaling 0.625, which means then our focus is 3.625, 2. So basically I took my vertex, and then since it's going to open this way, I had to move this way, so I added the 0.625 to the 3 to get my focus. My directrix, on the other hand, okay, this is going to be a vertical line, this time in x, but I've got to take the 3 and subtract the 0.625, and so the directrix will be 2.375. The domain, remember domain goes with x. The smallest this will be is 3, because that could be 0. Anything else, that'll be positive plus 3. So in this case, x is greater than or equal to 3. And the range, I can put anything in for y. So all real numbers for the range. And this is typical for domain and range. When I have a vertical parabola, it's generally going to be all reals for the x, and then the range will be limited by the vertex. When I have a horizontal parabola, the range will have all real numbers, and it'll be the domain that's limited by the vertex. Alright, so now that we have that, all we need to do is make a graph. So I'm going to go ahead and put it off to the side here. X and Y. The difference is I'm really going to be putting in Y's to find out what the X is. But we do know that in the middle will be our vertex. So let's go to 0 for a y. If we put in 0, so minus 2 squared, that's 4. 4 times 0.4 is 1.6. 1.6 and 3 is 4.6. So that means then 4 has to be 4.6 as well. Okay, let's go to negative 2. So negative 2 minus 2 more, that's negative 4. Squared is 16. 16 times 0.4 is 6.4. 6.4 and 3 is 9.4. And so 6 has to be 9.4 as well. Okay, let's go to negative 4. So negative 4, subtract 2, that's negative 6. Negative 6 squared is 36. 36 times 0.4 is going to give us 14.4 plus 3 will be 17.4, which means 8 has to be 17.4. Now we're already up to 17 on the x's. Probably the next one would be off the graph, so let's just go ahead and leave it there and go ahead and plug the numbers in. So first off, we have 3, 2 for our vertex, 3, 2. And then 4.5 about is at 0 for the y, so about 4.5 is at 0, and 4.5 is at about 4, so we'll put that right here. And then at about 9.5 we're at 6, and 9.5 we're at -2. So here's about 9.5 at -2 and at 6. Now, granted it's 9.4, that's not 9.5, but after all, on a graph with the squares this size, they're pretty close to the same thing. And then, let's see, we got 17.4 at -4. So, let's see, 16, 17, about 17.5 at -4. And 17.5 at 8. So here we go up to 8. So approximately like that. Let's go ahead and connect the dots. So this is a much narrower parabola than the other one because our 1/4p was bigger than the other one. So there's our parabola. Again, this is the vertex. Now the focus is only 0.625 away. That's 4, that's 3, so it's a little bit past halfway, but not much. So that is, I'll put it down here, that is 3.625 and 2. And that's our focus. Now, our directrix has to be at 2.375, so it's not going to be quite halfway. So something like approximately here will be our directrix. So again, this is at x equals 2.375. That's the directrix. Let's see that right there, which is at 3, 2. That's the vertex. This is the focus. And then we still need the axis of symmetry, which has to run through the vertex and the focus and be at right angles to the directrix. And so we'll just go ahead and put it right in there. And this is at this is our axis of symmetry, and it is at y equals 2. And so there you have all the parts for a horizontal parabola graphed. Alright, so to finish off, what if they give us a little bit of information? What would be the equation of the parabola? So here we have the vertex and we have the focus. Now remember that this one has y equals 1 over 4p x minus h squared plus k. Now you might say, well, how do you know that this is y equals instead of x equals? Well, here's our vertex. Okay, our vertex is at negative 2, 1. So if I were to graph that right above here, that would be negative 2, 1. So that would be about right there. The focus is at negative 2, negative 3. So the focus is actually down below so the focus is below the vertex. And since the focus always has to be inside the parabola, that means this one opens down. And so since it opens down, up and down means it's y equals the rest of it. Okay, now P is the y of the focus, subtract the y of the vertex, which in this case we've got negative 3 subtract a 1, which equals negative 4. So, since this is 4p, our equation will be negative 1 over 16, negative 4 times 4. Our vertex is at negative 2, so that means that has to be x plus 2, opposite sign inside the parabola, and then plus 1. And so having the focus and the vertex, we can get the equation for this parabola. All right, one last case here. We have the vertex at 1-2 and the directrix is at x equals 4. Now note that since they've told me this is the directrix, then I know that this one is going to open. Since it's x equals for the directrix, that means it's like this one here, it's a vertical one, so that means this has to be left or right. Since the vertex is 1, 2, and the directrix is further out than the 1, so that's the opposite of what we see up here, because this one, it was further to the left, so this one has to open to the left. Again, because that tells me the vertex is like here, but then the directrix is over in this direction. So, again, using our horizontal parabola form, 1 over 4p, and then this y minus k squared plus h. So, the p in this case is going to use the x of the vertex, subtract the x of the directrix, which will equal, let's see, the vertex was 1, subtract 4, which equals a negative 3. So that's my p, negative 3, 1 over 4p, so 4 times negative 3 would be negative 12. So this is negative 1/12. Y subtract 2, again has to be opposite sign, squared plus 1. And so there is the equation of the parabola, in this case opening to the left. So basically, if I were to think of this as sort of being the origin of it right here. So 1, 2. So 1, 2 would be like this. And then my p is 3. So 1, 2, 3, it would have to be there. And then 1, 2, 3. So, there would be the directrix, and this one would be going like that. So that's what the graph would look like if I did that. And so you have section 6.1.